My name is Ayla McCurl. I am on the comms team here at PSC. I also do DevRel stuff for PSC. Um, and today we're just going to dive into social connection, and we have three teams that will be joining us today. The first team that will be presenting is Cursive, um, and Vivek will be leading that. The second team is Grapevine, with Jack and Ian. And the third team is ZKP2P. Um, yeah, ZKP2P with Richard and Sachin. So it's really exciting to get into it and hear what these teams are up to, especially because ZK kind of has been a single player thing, but um, with these teams and with these projects, they're working on some really cool things that can turn ZK into like a multiplayer thing, which I think is pretty fascinating, pretty incredible. And it will be pretty cool to hear from these teams and see what their thoughts are on this topic and what they're working on. So without further ado, I will turn over the mic to the first team and first presenter, Cursive. So Vivek or Rachel, whichever one, you guys have the mic. And you can share your screen.
Cool. Thanks so much for that intro, Alo. I'm on my iPad. I'm trying to figure out how to do this. One sec. Okay. Do you guys see my screen? Hello? Okay, wait. Can't hear anyone. So do you guys see this like presentation?
Yes.
Okay, great. Amazing. All right. Yeah, so I was just gonna give a quick kind of introduction to different kind of directions of interest for our team, and then show a quick demo of something we shipped a few weeks ago at a conference related to these. So yeah, hi, I'm Vivek. I'm part of Cursive. I work really closely with Andrew and Rachel, uh, and a number of other collaborators that I'll get to highlight during this presentation. And our directions recently have been focused on using multi-party computation over social graphs. And we think like, at least one way of looking at this is that it can sort of enable discoverability in a more peer-to-peer decentralized way. So what is Cursive? Cursive is a research and design lab that's building cryptography for human connection. So very thematically relevant for this project spotlight. And in the past, if you've seen us, most of our projects have been around using NFC and signatures to digitize different physical interactions. So this could be meeting somebody, going to an event, getting some sort of in-person reputation, and you basically get a signature upon tapping like an NFC card as a like private proof of this. And then on top of that, you can essentially use ZK proofs to build different access control style experiences, whether it be like, exclusive events for people who have checked into a certain number of events or have engaged deeply with a community. And so want to walk through like sort of the pros and cons of the setup. Like one big thing here is full ownership and portability of your social graph, because everything is signed really special events and memories. And this can kind of be thought of like a private chain, some the same sort of value. And as I mentioned, with the sort of like ZK proofs and access control, you can verifiably reward loyalty to your community across different platforms because this data is portable. So what challenges have we run into with this setup? I think one thing is exactly what Ayla was mentioning, in that ZK is inherently a very single player sort of cryptography. It essentially enables you to make proofs about your own data. And we found that historically it's most useful for access control style things. On a similar vein, it's really good for coordinating with people you don't trust, in that you essentially are trying to like hide different amounts of information using tools like selective reveal. And we never really found it to be a really good connective tool. And finally, more of like a structural thing is that we were focused on sort of NFC data, but often you need more than that to build interesting applications, which is where tools like, ZK email and TLS Notary can really come to shine. And so, yeah, I guess what were sort of our next directions? The first sort of like multi-party computation that we explored is something called private set intersection. Private set intersection is a really simple idea. Essentially, you take two different sets of information. In this case, it's different like personal information about yourself. And you basically, with somebody else, compute the overlap between these sets. And in doing this, you only reveal what you two have in common. It doesn't reveal anything else. And we found this to be a really like easy to understand form of multi-party computation, as well as one that really can be an instant kind of icebreaker or way to connect with new people and even with friends you already have, just to learn more about them. So more information that we've explored that can make this interesting is using past event data and shopping history. Both of these can be pulled from your email, which are all going to be signed due to like the DKIM signature that's on all emails. And you can use stuff like TLS Notary to pull other types of interests, whether it be stuff you listen to on Netflix, Spotify, even interests that are more private to you that you wouldn't necessarily want to put out publicly, but could be interested in discovering if other people have those same interests. Under the hood, this uses a much more general technique called multi-party FHE. I'll go into a little bit more detail about how this works later, but this sort of slide is fairly descriptive of what goes on. There's essentially an initial MPC step to create a shared public key. There's an FHE step where you do some computation. In this case, it's just a multiply. And there's another 2PC step here, MPC step of decrypting this data. But yeah, I will avoid too many details there. Yeah, so as I mentioned before, we've deployed PSI at a few different events and activations. At ZK Summit, it was very simple. It was essentially like doing PSI over different NFC data. So, you could see common contacts that you guys had, common talks that you both went to. At the Signature Singularity Residency, we experimented with a sort of more immersive PSI where you could also import data from your email and essentially see overlap in like past events, in your interests. And the other nice thing about importing from email is that we could also import in the social graph for free. And the way we did that was essentially by looking at your calendar events and different payments you'd sort of made, both of which sort of like, paint a picture of your like overall social life and social connections without having to, go around and tap people. So I think this presentation goes on a bit longer, but I think I want to cut most of it just in favor of an actual demo, or at least sort of showing you guys what this looks like live. Yeah, this is, I guess, briefly on this slide, I guess I'll just say like, everything I've described to you has been very sort of like two-party. It's been between like two different pairs of people. But when we think about social graphs, I think the really interesting thing here arrives when essentially we're not just making computations. Okay, sorry. Essentially, like, we want it to be more than just like a two-party thing. You can start to then ask questions or learn things about your friends of friends. And it can also be something that's more, I guess, like complicated than just what do we have in common. One example I had here is essentially like asking friends if you're both going to a specific conference. And then you can essentially use this multi-party FHE setup to sort of surface this information. And you can imagine that this can go outside of just your initial connections. You can also be asking people in your extended network, like, hey, like, are any friends of friends going to this concert? Are any friends of friends looking for a job that I am trying to hire for? Yeah, I guess I'll just briefly mention like some sort of like kind of similar setups, or at least kind of like existing versions of this we have in the real world. One of this is dating apps. Dating apps essentially allow you to like match with people and get connection in that way, but it's very AI and algorithmic driven. And it's also like quite superficial, like it's based on some public information, like what people look like. So there isn't really much depth involved in dating apps. Targeted advertising is kind of a similar thing, except in this case, Google basically serves as a sort of intermediary where Google is matching multiple people with different like products and advertisements. And so a setup in which you can just do this over a social graph and use multi-party computation could essentially enable us to cut out the middleman here. Another one is dark pools, which I didn't have a good photo for, but basically it's a financial concept of private matching of orders between two different parties. Like someone makes a bid, someone makes an ask, and you might not necessarily want to put that on the public, like on the stock market, because it'll lead to sort of price changes. But dark pools enable this sort of matching with privacy. And that's kind of the same thing that's going on here. Is you're essentially you're making kind of a bid and an ask, or like an offer and a request uh, through these sort of MPC queries. Okay, I will skip the rest of this in favor of a live demo. So I'm going to quickly switch to Discord on my computer. Give me 1 sec. Hello, can you hear me? See thumbs up. Wonderful. I can't hear anyone. That's worrying. Whatever. Okay. So let me screen share here. Give me 1 sec. Okay. All right. I can see that you guys can see it. Okay, cool. So I wanted to give an example of kind of a lot of what I've just mentioned coming together in like a cohesive app experience. So this is an app that we built for a recent conference called Frontiers, which was held in San Francisco a few weeks ago. And it's basically a mix of a lot of different things that I shared with you guys. So one thing was essentially all attendees got some sort of NFC chip, and upon tapping different people, you essentially built up like a big list of contacts. In each of these different things, like we can go to this one, like essentially a couple of different things that we pulled up, just like their socials, but also something we did for this conference in the realm of sort of adding more interesting data to do multi-party computation with is we imported people's GitHub information. It was a very developer focused conference. It was like a Rust open source dev conference. So we basically, upon tapping, you could learn a bunch about, which repos someone had committed to, what repos you had in common, all that sort of good stuff. And all of this stuff is essentially, it's a signature, everything is signed, and everything is private to you. So what that enables you to do is you can make different proofs about your experience. And so in this case, different proofs we enabled were basically just sort of like depth of engagement and kind of just for, bragging on Twitter. We didn't really have like a big incentive loop to do this. It was more of just like a tech demo that you could make proofs about your collection. So in this case, it was basically make a proof that you met 5 different people as an initial thing, make a proof you've met some speakers. Oh, and actually, okay, this Frontier Superconnector proof was meeting 50 people, and actually we did have a prize for this. You essentially got to win like an NFC ring. So there actually was a little bit of like a kind of, verify your engagement and get rewarded for it. And then what I want to share is basically a initial version of this sort of MPC matching, where essentially we let people fill out a like job profile if they were a recruiter. And if they were a candidate, we let them fill out sort of like a job qualifications form. I don't have that here because I already filled it out. But essentially, what this would enable people to do is to privately set up a either like a profile or a qualifications and post that encrypted. And so what would happen is every time you tapped someone, essentially we would do a computation privately to see if your kind of like postings match each other. And that like, for the candidate, their interests matched what the job had to offer. And also like one thing where privacy is really useful here is around salary. So we want to make sure the recruiter is offering a salary that's higher than what the candidate is willing to work for. But you don't even necessarily need to surface that publicly. That can happen further down the line. It can just sort of be verified privately that these things are compatible. And the other reason that we think like privacy is really interesting here is like for me I applied basically or like to test this feature. I was a candidate, and as a candidate, you might want privacy over the fact that you're searching for a new job. In case you're currently hired somewhere and you don't want your employer to know that you're kind of like looking around for new opportunities, or if you're just embarrassed about the fact that you're currently, don't have a job, this should be something that you don't need to like publicly put on blast just to sort of, get the best opportunity for yourself. Instead, you can just post a private description of what you can do and get matched with other people, if there's overlap, essentially. And one other really important feature here is that the flow is very candidate centric in that essentially the recruiter learns nothing until I choose to share my contact with the recruiter. So I can basically see all these different roles that I think, basically overlap with my experience, with my salary requests, with my interests. But in this case, Andrew, the recruiter, does not see anything until I choose like share your contact. In which case now basically like this will show up in Andrew's feed and Andrew can reach out to me to, set up some sort of like further this conversation. One other fun thing I'll highlight is as you went through the event, every single person has a unique, like generative art flower that represents, it's sort of like generated from their public key. And so as you go through the event, you essentially build this little flower garden of all the different people you've met, all the different events you've attended. In this case, it was just around people. So these are all just individual folks I met. But Cursive is also really interested in essentially using design, UX, and interaction patterns to try to communicate different parts of the cryptography to different folks. And in this case, each flower here just represents like a different signature that you have collected. Yeah, I think, oh yeah, there's a leaderboard too. This guy went crazy. He got a lot of taps. I think that's all from me. I think we're doing questions at the end. So I think I will just pass it off to Grapevine next.
Well, we're gonna do like quick Q&A, and then we'll do like
Correct.
expanded questions. So if anyone has like any pressing questions for Vivek right now, go ahead and ask. I know it was a lot of information to take in, some pretty cool stuff.
Yeah, I got one. For certain like when you're grabbing things out of email or like CKTLS, if you want to call it that, and then feeding that into the 2PC PSI or MPC, the private set intersection. When do you find that it's like required to do those inputs, and then when do you find you can just like have the users like put it in manually test?
Yeah, this is a really great question. I think like something that's been really interesting about our work here is that actually, yeah, a lot of stuff is totally fine to self-attest. Or at least like if you, maybe the heuristic here is like if someone is to gain something or like like sort of win some points for having certain data or like overlapping on certain things, then in that case like you should probably have it be verified. Like maybe one thing here is like if you prove that you have both gone to like, or actually not, this is less an NPC thing, more of a ZK thing, but like if you prove that you've gone to 5 Taylor Swift concerts, you get a discount on the next one. Like, yeah, you really do need verifiability here. You can't just let people self-attest this. But if it's something like I'm just gonna put out the music artists that I like, um, and I want to find people that have a bunch of overlap with me, like I don't really gain much, at least if I'm trying to find good connection with people, I don't really gain much from like lying and saying like, oh, like I really like XYZ artist, when I really don't. So I think it's just kind of a case by case thing. And yeah, it just depends on like both the setting that it's kind of being asked in, and also another relevant detail is like how close you are with the person. Like if this is your best friend, it's probably fine to like you have trust. You don't need to have everything be verified if you're discovering things. But if it's someone who's like 2 or 3 hops away from you on the social graph, that's probably somewhere where you want to um, like have like verification on the data that you're matching with or being asked about.
Okay, awesome. For the purposes of time, we're just gonna go ahead and move to Grapevine. But thank you so much, Vivek and the Cursive team. What you guys are working on is amazing, and we will definitely get to that after these next two presentations, right? Um, so next we have Grapevine. Um, so Jack, Ian, you have the floor.
Cool. I cannot stream into this channel, apparently.
Oh, you can't share your screen?
Yeah, it says I can't. Yeah.
Oh, you can or you can't?
Oh, it's a I can't.
Okay.
Oh, there we go.
Okay, you got
Try
it.
now.
Just all right. Do window for now. Okay, that looks like it's going through. Well, so hey everyone, we are Mach 34. I'm Jack Gilchrist. Got Brighton sitting next to me. We've been working on Grapevine, which is a utility for building private, verifiable social graphs that show distance from identity. And this is cool because we can build apps that rely on purely to attest in some way to validity of an identity and some other attributes potentially. So we'll run through the basics of like what's being proven. We've got a JavaScript library, but it's not exactly feature complete yet, and it's very messy. It does mostly what it needs to, so like it's cool to look at. But we'll kind of show off the CLI and talk through how that's useful in JS, and talk about some next steps. So yeah. So I'm gonna run through the protocol very, very quickly. There will be time for some questions for clarity at the end, but yeah, I'm not gonna explain everything. Also, addresses are just the hash of pub keys, baby jub pub keys. So to start out, zoom in. Yeah, to start out, essentially, like this is all based on relationships, right? That's kind of the atomic part of a social graph is the actual edge between two nodes. And in Grapevine, identities exist essentially just as baby jub key pairs. And in order to form a relationship between two users, they're going to issue each other auth secrets. And I'll run through that very quickly. First off, we got to drive a nullifier. I'm not going to talk too much about it, but essentially it allows the derivation process just makes it so that you can't just randomly emit any nullifier. You have to emit your own nullifiers. And then essentially, here, let me see if I can go into this. Essentially, what we're going to do is we're going to take the nullifier and going to take the recipient of this auth secret, their address. We're going to hash them together, and we're going to sign that with the sender. And what this does is it says A, that the sender is saying, I know this recipient, and B, it's saying that this nullifier bound to this recipient can be used. We'll see that's important in a second. So then getting into the actual proving flow, can I open this one new tab? I can. So I'm glossing over a lot here, but we're using like Nova style proving or folding currently from Nova Scotia, which is really nice. Gives you a circom front end for recursively folding proofs together. But like if you're interested in playing around with it, we're actually implementing Sonobi now into this, and you should definitely be checking out Sonobi's. That's kind of the current standard. So yeah, this is a uniform IVC, incrementally verifiable comp, meaning that like every instance is the same. So we're just multiplexing some logic depending on whether it's the first step or subsequent steps. But essentially, there's like a couple main things that are passed between each step. that allow us to make the actual assertion of our proof, which is the scope. That's like who we're proving distance from. The relation, which is who's proving that distance from the scope. There's the degree, which is how far away they are. And then there's an array of nullifiers, and these allow us to anonymously basically like break relationships and all the downstream proofs without destroying the entire social graph or revealing identities. So I'm not going to talk about the identity proof. It's basically just proprietorship over the pub key that is the actual identity here. But for the degree proof, essentially, we're taking that nullifier in auth signature that we talked about exchanging here, as well as a signature by the prover over like the actual scope, like who we're proving some degree of separation from. And we're going to take those. We're going to make sure that the signature used in, or the key used in the auth signature is the same as the relation, so that we're using like we're building off the previous proof. We're going to also check that because that's going to constrain the address of the prover. We're also going to check the scope signature, which essentially proves that we're allowed to use the address that's attested to the auth signature. So again, I'm going a little quick through it just to be mindful of time. But essentially, it's just to check that the previous prover is allowing you to build proofs on top of them, and that you are the one that the previous prover said can build proofs on top, as well as constraining the nullifier. And you see that as we get further and further down, we've got proof that Charlie is 2 degrees of Alice, and these are the nullifiers that were used. So you can basically check these nullifiers as they're emitted to see if the proof is still valid, or if it's a new proof, whether it can be accepted. So I'm gonna run through what? Hold on, sorry. I'm gonna run through a quick demo of open the terminal. I guess I just use this. Not okay, cool. So yeah, we've got a JavaScript library. Again, works pretty well. Just not quite what we would want to show off, but we'll talk scope of like how you would use it. So the very first thing that you're going to want to do is you want to register an account. And this is actually going to create the identity proof right here. And this essentially allows anyone who you build a relationship with to build proofs on top of it and say they're 1 degree of separation away from you. We actually store the keys just like in the file system. In JS, obviously, it's a lot more to the developer, how they're going to implement it, but now we're just going to use this hacky way of switching accounts, so it might get a little annoying, but it's not what the actual JavaScript looks like. So this is a social graph, right? So like we need multiple people. Wouldn't be much fun with just a single account. So we're going to do that as well. Okay, I think I might have misnamed Alice there. Whoops. Okay, that's fine. And then we're actually going to add the relationship with are like they require mutual consent in this paradigm, meaning that you both have to exchange the relationship addition process, at least through the server. So switching back, also actually you can see again through the server. Let's see. Yeah, we got a pending. Don't actually need to use the server though, is the thing. Like really the server mainly exists as a repository for the nullifiers, as well as a coordination mechanism we'll talk about in a minute. But that's like the big thing. Like you can totally exchange these proofs out of band.
Real quick,
And that
are you actually like making changes on your screen right now? Because we're not seeing anything. We only see VS Code.
no.
Oh, you're just on yeah, you're just on this index.ts file.
That sucks.
Oh no,
Okay,
it's okay.
my bad.
That was fine.
This one. One. How do you see terminal?
Yes, we can see the terminal.
Okay, so yeah, we registered the account at a relationship. We're about to add the relationship back. Okay, and now we're Bob. We've added the relationship. We've done the nullifier sharing, so we can do Grapevine proof sync. And this is going to essentially prove 1 degree of separation from Bob. And this is just gonna get one, like all the proofs, but JavaScript library will allow you to pull whatever proofs you want, as well as potentially like if you've got multiple routes for the same scope and the same degree, you can like choose which route you want to go through. So yeah, that's cool. We've done 1 degree of separation, but what if we want to say Alice knows Charlie, and Alice also knows Bob. Charlie can then have a 2nd degree of separation from Bob through Alice. So set that up really quickly. Again, this is all driven from a command line, but with the JavaScript library, the idea is to put this into a more compelling user experience. We've kind of just built the skeleton for actually doing this. So basically what I did is I added another account and then added a relationship between Charlie and Alice. So now as Charlie, we run the sync, and obviously Charlie can prove with Alice because it's degree 1. Also, using Alice's proof of degree 1 separation from Bob, Charlie can build a proof of degree 2 separation from Bob. And we can see Grapevine proof scope. Okay, so I think in the interest of time, I'm not going to run through nullifiers. Essentially, what you can do is like Bob could nullify the relationship with Alice, and that would invalidate not only Alice's degree 1 proof, but Bob's or Charlie's 2 proof. So I guess I'll just talk about really quickly moving forward. Where is this useful? We think anywhere where you can like derive attestations from social consensus. So an idea we really like is to build a sort of Ethereum name service where instead of like having domain squatting, essentially determining which Vitalik is the real Vitalik, seeing how strong your social graph is connected to them. So like Twitter, if you've got one account that says it's Vitalik and it's got 800 followers, and another's got 2, probably the one with 800 is the real Vitalik. And just keep it moving. Other tech we want to implement, if you know about folding, you probably know that you can't just pass folded proofs around. Contains sensitive aggregated witness data. Had this whole chaff step scheme that Sora from ZK email totally blew apart. But the new Hypernova paper has a proposal to add ZK into the folding step of regular Nova. And I believe Pierre, who's working on Shinobi, has actually already merged in this functionality. So we were already going to implement Shinobi, but I think we get that as well. But if not, we'll be hacking around that. As well, like there's this problem of like the server can see all this stuff. Specifically, like the relation coming out of the proof, I think is the most dangerous. So like I know some people are like really against trusted execution environments, but this wouldn't be securing millions of dollars, so the cost of an attack would probably mitigate the threat. Um, we think that like the solution that Signal uses for contact discovery would probably provide a really efficient UX for like when you do Grapevine proof sync and you go look at all the proofs you have available, essentially using secure enclaves for that. So yeah, I think that's pretty much it.
Awesome. Thank you so much, Jack. That was really, really cool. Questions, anybody, before we move on to ZKP2P and the open discussion? Okay. So no questions, but thank you so much, Jack. That was Grapevine, everybody. Super cool. We're definitely gonna dive into that a little more after this next presentation. Because of time, um, we have to keep it moving. But thank you so much. Okay, so next we have ZK P2P. Um, we have Richard and Sachin who are going to present. So you guys have the floor. Take it away.
Cool. I think I also need streaming permissions to share my screen.
Okay, working on that.
Cool.
Try now.
Awesome. Yeah. Uh, oh, cool. I think I got it. Cool. Yeah, I'll get started really quick. All right. Hey everyone. I'm Richard. Sachin from our team is also on the call. We'll be taking K2P and what we're minimize a P2P marketplace. And Sachin will also give a demo. Cool. Yeah, just a little. I have a couple quick slides review on what we're building. Exists in walled gardens. This can make kind of exist market master any kind of like platform. And pretty much customers allows these projects to be predatory in pricing and allow like negative externalities to exist, such as fraud and scams in the case of marketplaces. The solution is programmable cryptography plus Ethereum. So ZK and MPC and all these new data primitives allow for new inter-app data pipelines, and you combine that with Ethereum and blockchains for global settlement to create all kinds of interesting new workflows. And this kind of brings us to ZKP2P, which we aim to combine both of these like new technologies to create a Web 2, Web 3 bridge that can help bring faster, cheaper, and lower fraud transactions compared to existing marketplaces. Cool. Yeah, just a quick like overview for those who are unaware. Our first zkp2p product is an on-ramp where it's currently live in production, and it's a pretty simple construction. So initially, the seller locks crypto assets in an escrow contract and provides an off-chain identifier. The buyer sends the off-chain payment to that ID. The buyer generates a proof of payment and submits that to the verifier, which is a contract. And if the proof is verified, the contract unlocks the assets to the buyer. Enables what we call non-interactivity, where buyers can unlock their funds synchronously as part of the on-ramp flow. So it's very fast for the buyer. So it turns out you can kind of generalize this construction to not only fiat transfers, but any kind of digital asset transfers. For example, like domains, tickets, in-game items, digital gift cards, and more can be transferred like in existing applications. We simply just replace the off-chain payment with an off-chain asset transfer and generate a valid proof of transfer rather than a proof of payment to unlock assets in the escrow. Because of this like more efficient workflow, these marketplaces will have no fraud and way lower fees than using traditional Rails. And here's a quick, I guess, like diagram of like our explorations currently. There are various like ZK and MPC primitives that we have used and have productionized and are productionizing as zkp2p to bring like the internet data for use in these on-chain marketplaces. So we've used ZK email, TLS notary, and we're also experimenting with a proxy TLS flow with Reclaim. For example, like our Venmo on-ramp uses ZK email, our Revolut integration, which is live, uses TLS notary, and some of our upcoming marketplaces will use a proxy-based TLS flow and a combination of like several of these primitives. I won't go into the details today for time, but yeah, I want to leave most time remaining for demos. Cool. So today we'll be demoing like our upcoming domain P2P marketplace. I think this is the first time we're showing this flow to the public. And yeah, I think I'll let Sachin take over from here.
Cool. Can I have streaming permissions, please?
Try now.
Yeah, thanks. Cool. I'll give a quick demo of our new domain marketplace. I'll go over first verifying and registering a domain on chain by proving ownership of the domain. And then I'll create a listing, and then finally we'll complete the sale. So get started. So in order to list the domain on the marketplace, first the seller has to prove the ownership of the domain, for which they would generate a zk-TLS proof. Like we require the domain to be registered on Namecheap, which is one of the registrars out there. So select a domain that I've not already registered. Let's choose this one. Yeah, I'm generating a zk-TLS proof. It is specifically zk-TLS, not MPC-TLS, because we are using the TLS proxy flow. Cool, the proof is generated. I'll head back to the app. There's this. Yeah, I see the proof here, and I will register the domain on chain to claim ownership of the domain. Right now, the app is deployed on Sepolia, which is in the Ethereum testnet, and the transactions are a bit slow there, so we'll have to wait for it to be mined. Okay, so we have verified the domain on the domain registry on chain. So now we can go ahead and list the domain for, let's say, 1 ETH. We'll create the listing and send the transaction on chain. As you can see here, like we charge a very standard flat 2.5% fees, which is much less compared to all the other Web2 secondary marketplaces. So yeah, my domain is listed on chain. Here, refresh the page. It's still work in progress. Yeah, so my domain is listed on the marketplace, and now I'll wait for Richard to bid against the domain. Also, for context, this is our sidebar extension, which hosts the TLS proxy prover, as well as we also have integrations for TLS notary prover. For example, the Revolut one uses the TLS notary prover. So this is one extension that allows you to generate multiple ZK TLS. Let's see if Richard. Yeah, I see Richard's bid here, and I can now go ahead and finalize the sale. So I'll go here, go to the domain management page where I have to first transfer the domain to Richard, authorize the domain transfer on Namecheap, and then transfer the domain. Now, because Richard has enabled automatic accept, which I could see here, he has enabled automatic accept. That means the domain is immediately transferred to Richard's Namecheap account, and I should get an email for transferring the domain directly from Namecheap. So as a seller, I log in into the app with my Gmail account, and I see that I've recently transferred the domain to Richard, and now I can essentially generate a Groth16 proof using the ZK email library to prove to the contract that I've transferred the domain to Richard. This will take a while because right now we are using the WASM witness generation, but we will soon be switching to the C witness generation, which is way faster and should be done under 10 seconds. Also, the reason we do not use ZK-TLS proofs for proving that we have transferred the domain is domains are way more, they're a high ticket transaction. So they could be anywhere from $1 to millions of dollars. So we are going for signed data, which is way more secure compared to ZK-TLS proofs. And our understanding is whenever there's signed data, always go for signed data. And if you do not have signed data, then go for MPC-TLS or ZK-TLS. So I'll complete the sale. Oops. Is that working? That's still work in progress. Nullifier has already been used. Yeah, it seems I have already. I'm getting an error that nullifier has already been used, which I think it's because we tested this once before the demo, so maybe it's not going through. But trust me that it works, and you can see the Groth16 proof here. So yeah, it's still highly work in progress, but we wanted to use this platform to show the very initial demo of the domain marketplace.
Thanks so much, Sachin and Richard. I think that was the end of the presentation, right?
Yep.
Okay, cool. That was amazing. My mind is blown from the 3 projects that have presented so far. Um, like, yeah, I mean, now is the time for open discussion. I mean, we only have 6 minutes, so if anyone has any pressing questions or something they want to bring up in revolving social connection, this will be the time. Um, yeah.
I just wanted to say like this kind of cross-functional use of zk-TLS and zk-email and potentially TLS notaries, like super interesting. I didn't even know you guys were doing this, and yeah, that's like something, or like it's a level of nuance that I haven't seen a lot of projects try to get to, and I really appreciate like the deep thought there, and also the like just like ability to ship multiple solutions is like really impressive and crazy. So just yeah, kudos to you guys.
Yeah, thanks, Vivek. Shout out to all the all the projects that built out these ZK primitives, because without them, we wouldn't be able to build any of our products.
Yeah, I think Sino said signatures are king. Um, when I found out about digital signatures, my mind was blown. Um, the amount of things that you can do with them, and the teams that are using them, such as ZK P2P, Cursive, ZK Email, all of those, like they're coming out with some really amazing primitives and projects. So I would definitely suggest checking all of these projects out. Um, yeah, and I'm really happy that I had or that we are doing this topic of social connection because I think it's a really interesting one, as you can clearly see. Um, you have in-person activations with Cursive. Um, you have you're able to sell a domain using ZK2P and so much more. So very exciting stuff, and I cannot wait to see where I guess this space grows in terms of social connection. Um, yeah, one question I actually did have for Vivek and the Cursive team is like, if I'm at a conference and I notice that I have, I don't know, something in common with someone, I mean, is that like, do I get to choose whether or not that person gets to see that we have something in common? Like, I'm not too clear there because I might not want to, I might not want the person to know that we even have anything in common.
Yeah, it's a really great question. It's The short answer is it's something we're actively trying to work through in terms of like design and UX. And I think the rough setup here is that like it should be something that is like a progressive disclosure. It's sort of like in your initial interaction with someone, it's probably just like you share a Twitter, you share some sort of really base information, and then um, as both parties connect more deeply, whether it be like meeting up more times or discovering they have more mutual friends or like just deciding to share more information with each other, then you can discover more and more in common. But yeah, I think we're still iterating through like what the interface and UX should be like for that, so that that feels natural and smooth. And I think like the sort of like worst case here is like I don't know, you don't want it to feel too much of like a credit score or something, or sort of like I don't know, we're all like rating each other in different ways. Like you want it to feel much more like smooth and safe and like connective. So yeah, it hopefully by DevCon we'll have some initial iteration, but I think it's just a difficult problem that we'll keep iterating on.
Awesome. And my last question actually is in revolves to like the collaboration between Grapevine and Cursive. I definitely noticed that there's some synergies. So wanted to know if like is Grapevine incorporated in the way that I guess Cursive um, pinpoints friends of friends, or how is that actually working?
Um, I mean, we've At ZK Summit, we built like a ZK Summit folded thing, which is not the same as Grapevine, but I was kind of dipping the toes in the water on it. We would have to switch out the signature scheme, which would not be very much work at like the circuit level. But there's definitely a way to bolt it on. It's probably a conversation that needs to be dived into more, but there's definitely the possibility there. Yeah.
Yeah, I think it's looking like a medium to long term sort of like integration of just like I think both of our teams have been trying to figure out like both on the tech side and like UX side like yeah, how to get all this stuff like working and have nice UX and yeah, I think down the road there will be a very natural way to combine the best of each into something really sick.
Okay, awesome. Thank you guys for presenting today. That was really, really cool. I hope everyone gained some value from this conversation and these demos. This is episode 2 of Project Spotlight. There will be a recording that will be released later this week or early next week. So share it with your friends or whoever so that they can also get some of this alpha. Again, want to say thank you everyone for coming. We are at the top of the hour, so I'm going to be closing the space now. So thanks, guys.
Thank you.
Yes.